Hello, 1, 2, 3. Oh yeah. Oh. Hi. I think it's just two of us. I think when they checked yesterday for the amount of people registering, it was just your one person. So you've got a bespoke session today.
Hiya.
Hi.
Can you hear me?
Yes, I can. Fantastic.
It was only one. Yeah, I didn't know it was only one participant. Do you want to postpone it? Do you want to do it another time when there are more participants, maybe?
I think what they said is for us to run through it and to record it, if that's okay with you.
Yeah, that's absolutely fine.
And then they can share it, and then certainly we can blitz through and go through things, and then just have a discussion between ourselves as well, if that's good for you.
Yep.
No problem. Okay, so shall I introduce myself, and then it'd be great to find out your background as well. So my name's Raj. I'm currently teaching physics at Dulwich College in South London, and I'm the chair of the ASC London region, so it's Association for Science Education, and I'm also do a bit of work for STEM learning as well. What about yourself? Petya, is it?
Yes, yeah, Petya. I'm a secondary school teacher. It's my second school, this one. I'm a recently qualified teacher.
Oh, great.
And
what's your subject specialism then?
Well, it's chemistry, but funnily enough, I'm not really teaching any chemistry to GCSE level this year. It's mostly biology and physics.
And what key stages are you going for?
Key stage 3 and key stage 4.
Oh, okay. And what's the school like that you're based at?
Well, I'm actually teaching in 2 schools at the moment because I am employed by a new school that is a guest of an older school. And because we are a new school, we only enrolled year 7s this year. So that means I'm teaching 4 year 7 classes because that is our capacity really. So I'm their science teacher, but I'm also teaching the other schools, year 8, 9 and 10.
So you based on the site of the second school?
Yes, yeah.
Oh, right. And then presumably once you move to your new site, once you get a few more kids after a while, then will you have to set up the science curriculum and things like that yourself?
Well, hopefully there should be a head of science, because I am just a science teacher. I'm not really a head of anything. So I'm just following the curriculum at the moment. We are waiting for our building to be done. And yeah, once we move in there, hopefully there will be more science teachers and there will be a head of science that can probably amend the curriculum a little bit about the new school. I don't think we are going to be exactly using the same one as we are doing at the moment. I'm not sure.
Okay. So they'll make decisions suited to your. And what's the students like for the new place? What's the background of the students?
Oh, it's a mixed ability, a mixed background. It's based in Colchester.
Okay.
So yes, you can find any sort of backgrounds really.
So a bit of everything. Oh, fantastic.
Yeah.
So what I was going to do is I was going to go through it. There's a few things that we were going to do as a discussion thing between the participants, but just because it's just the two of us, we'll see how those go. But I was just going to go through using AFL basically, and then actually responding to feedback as well. So firstly, I suppose the question was, what would you say makes an effective school? And you're in a school that's growing, and as it gets bigger, you want to start to adopt those practices that make it effective. So what would you say would be an effective school? What would be an effective science department?
Well, the curriculum is really important, I think, and it's really important to make the links between all of the different subjects and not just in your subject. However, in science, I've already noticed that some of the links were not in place maybe with some of the topics that I'm teaching at the moment. So that makes, I think, my life a bit more difficult, I would say, and my students' lives as well, because then we're spending a lot more time me teaching things that are not really in the topic that I'm supposed to be teaching. But then we have assessments to catch up with and all of those things that could have been done in a slightly different way, I would say. So curriculum is definitely one thing that makes the school stand out.
Is
Makes
that
it
the links between different parts of the science curriculum, or the links between the science curriculum and, say, the maths curriculum that supports it?
both, really, both.
Okay. Cool,
There
cool,
should
cool.
be links between the subjects, definitely.
Yeah, and maybe even studying similar things at similar times and things like that, or for example, in graphical work, knowing what the students have studied about graphs and maths before they
Yep.
look at graphs in
Yep.
as well.
Gradients, things like that. Yeah, absolutely. For example, how to rearrange equations. I'm teaching it, let's say, in the beginning of year 7, but they haven't really done it in maths, and that doesn't really make sense to the students when they come to me and I start teaching that. So I need to put a lot of scaffold in the way I'm teaching it to make it work for them, because I can't teach magnification equation without them knowing how to rearrange the equation. So yeah, things like that should be definitely communicated between the departments, I think.
Okay, so one of the things I wanted to share with you was having a look at what the EEF says is effective effective teaching. So the EEF is an organization that does a sort of meta-analysis. So it looks at lots of different research papers and sticks them all together to have a look at the impact of different things that people do. So if I chuck this into the chat, this link.
Okay, bear in mind, I am on my phone because my
Right.
computer won't allow me to download Zoom, so I can't log on with my laptop. I do
It's
apologize.
better if I get them to send you these links afterwards.
Yeah, I think I have that one because that was shared on the inset day with us.
Oh, great.
Yeah.
Fantastic. So this is a really nice kind of meta-analysis of what's effective and what's not effective. And so you've got the cost, how secure the evidence is, and the impact in terms of months added onto the student's progress. And you've got some things. So the most effective thing here is metacognition. And,
yes, that's the same thing we discussed on Monday, I think last Monday.
Oh, yeah. Great, fantastic. So you've seen it before. So
Yeah.
one of the things that I wanted to have a look at is feedback in particular in this session, which is cheap and it adds 6 months. And the other document that's probably quite useful, which is science specific, is this one. Have you seen this one before from EEF?
I can't really see anything. Let me just see if I can go onto the chat. Sorry, it's gonna take a while.
It's the EEF Improving Secondary Science. So,
I can't really see anything.
well, can you see my screen?
Yep.
Okay, so we've got 7 recommendations that the EEF say for science in particular. So the first one is having a look at preconceptions, so things that the students think about already and what they believe already. Self-regulation, which is linked to metacognition, the idea that they understand their own learning and they direct their own learning. Using models, retrieval and memory work, practical work, language of science, and finally feedback. And again, one of the things I want to have a look at is feedback and also the preconceptions that the students have. These are really our kind of 2 main resources that I would suggest we use when we're looking at our kind of longer term planning and strategic planning to do with what we're doing in schools and what we're doing particularly in science departments. So with that in mind, have you done some AFL, and what would you say AFL looks like within your classroom?
Oh, I'm constantly doing AFL. I think that how I'm teaching my lessons is based on AFL.
Mm-hmm.
I'm just gonna close my door.
So what kind of things would you do? What would that look like?
Well, I am using a lot of code calling, questioning, asking why, how, so they can improve their answers, give me better words, whiteboard quizzes, all of that.
Oh, fantastic. And what kind of data do you get out of the students from there?
Well, I do multiple choice quizzes as well. Well, it is going to be the whole class understanding with some of them, like mini whiteboard quizzes. I can find out approximately how many or what percentage of the class understands what we've done. Then if I'm asking probing questions like why, how, then obviously that's the deeper understanding of the topic. And I'm constantly asking those because I'm not moving forward if I don't get the right answers there.
I really like that.
I'm just
You're not moving
really
forward.
cautious about the language that they use because because it's those little things that can trip them over during the assessment. So I'm trying to be as explicit as possible, and I am trying to get the right information out of them before we move on. So constantly bouncing off questions one to another, help each other out, whatever is needed, just to get the answers out of them.
Great. And how do you choose what questions you go for? How do you decide which questions you're going to use for AFL?
It depends really on the topic. It depends on what I'm trying to assess, I suppose. If it's something that needs practice, like calculate something, then it's going to be mini whiteboards because that's the easiest way to see how many of them actually have found the right answer. If they have the right answer, obviously they know how to calculate it. If it's something that requires a bit more explanation, then I'm going to be asking one by one to see how many can actually give me a reasonable suggestion on why and how. I don't know.
So one of the things that I really liked that you said is that the idea that you're quite stubborn with your AFL in terms of moving on. And you said you wouldn't move forward without the students all understanding that. So you're actually using that AFL and acting on it. Often when we go into lessons, whether as part of school inspections or things like that, you'll see sometimes it can be quite tokenistic. So people will get those mini whiteboards out and they'll do their mini plenary or so on and so forth. And then what they'll do is they'll move on, regardless of what the students have said. So sometimes students will get, or a proportion of the students will get the question wrong. And they'll say, okay, so-and-so percent of students made progress on this unit, but so-and-so percent didn't. And then they'll still move on. And I think you're exactly right to say, okay, I'm not going to move on to that next topic, but instead I'm going to stay on it. And if necessary, changing your lesson plan, changing the structure of things and going through things another way. So it's really nice to actually have AFL as something that kind of signpoints what to do next. So what we've got here is a little excerpt from a piece of AFL. A sort of teacher guidance thing. And what it says here is how to respond, what to do next. And the students have been asked a multiple choice question. And the answer, the most common wrong answer, they said was such and such 1C in this case. And they said that common wrong answer tells you far more actually than, okay, yep, they got it right. And what it's got in here is what to do afterwards. So it says, if they've said such and such answer, I'm going to do this. If they've said another answer, I'm going to do that. So these resources are up on the BEST website. I don't know if you've had a chance to have a look at those. Otherwise, we can have a look together.
I did just click over them because I didn't really have the time today.
Well, shall we base it on something that you're doing? Are you doing a topic soon, maybe this week, that's that we can have a look at together?
Well, I'm doing quite a lot of electricity at the moment, key stage 3 and key stage 4. Okay. And I'm doing biology photosynthesis, I think, with key stage 4.
Have you got a preference, electricity or photosynthesis?
Electricity we can go for.
Yeah, let's have a look at that. So let's have a look. And would you say any one of these concepts? Electric currents, voltage, static, resistance, parallel circuits?
Yeah, current we've done.
Okay, so if we download these, so you need to sign up for this, but it's free.
Okay.
And these are all research driven. So if we have a look, what they've got between each other is they've got a PowerPoint presentation here. So it says here on the circuit, the bulb is lit and there's a reading on the ammeter, which is the picture of the ammeter. And then it's talking about what's the ammeter measuring. This is maybe a little bit overly simplified. So along the PowerPoints that they've got, each one comes with a Word document. And you can either give this, you can give this first sheet out as a worksheet. And then it's got what the research says about this this question. So these questions are research driven. So they're quite nice questions. They usually throw up some interesting answers. And again, how to use it. So in this case, they suggest completing it individually and getting them in. The correct answers here, D and A. And then how to respond next. So they said it's still got, for example, for the second one, they may be confusing the ammeter with the voltmeter and taking voltage and current interchangeably. So
and they mix them up a lot, don't they? Yeah.
Yeah, I'm talking about flow. And then I suppose the other thing is how they're connected as well within there. So what you might do then is move on to another one. So if they did all right with that one, let's come down here and do something a little bit more complicated. So this is now a sorting task. So you pick one thing from the first one, and then from the second one of the second two, you choose which one is correct, and the three ones, and so on and so forth. So with this one, the way that you might choose to use it in class, again, perhaps I would suggest giving it out as a worksheet. Oh, this is not the right one. Here we go. Giving out a worksheet like this, I think you could probably print these two up, so you could have them 2 on an A4, so you save a little bit of paper. And your correct answer is this way round. But what's quite interesting is to say if the student chose 2A in this,
then that's going to lead to something else that is not right, probably.
Yeah, so it's the idea that they'll probably have an idea around the idea of recharging a battery. That will be their kind of core thing. That all the charge is held in the battery and that there's no charge in the wires. So in that case, what that would point to is that if they chose option 2A, the first one, then what you might want to do is you might want to go back to something like your atomic theory and talk about electrons and say, okay, right, in chemistry, we know that there's free electrons in there. So there are these charges in the wires. And what the battery is doing is it's putting a PD to make those charges move, but those charges aren't all just held in the battery. Again, it's a similar kind of conversation if they choose 3B or 3C. And then the nice thing about this is that, again, you've got, for example, if they choose 4A, then you've got this bit of text here that explains what they're thinking there. And then 4B, you've got this bit of text there. So the idea around these best resources is that you use them for AFL, but the questions are already written for you. They're based around research, so they are fairly well justified. They're quite good at kind of picking out those little misconceptions. And the nice thing is that they tell you what you can do next. So if the student says this, you can do that. If it says that, you can do that. Have you got the kind of classes where you might be able to split them up? If some students say one thing and others say another thing.
What do you mean by that, split them up?
So, for example, if you use one of those best resources, and some students said option A and some students said option B, would you therefore be able to quite easily differentiate them and say, okay, for you, your group that says A, you can go and do this task, and if you said B, you can go and do that task?
I suppose I can. I don't know whether we are still allowed to do seating changes that much because of COVID. That's my only issue with that.
Oh, okay. I know at our place where it's just starting to kind of the restrictions are just starting to go, so it's been quite
same with us, but yeah, I'm not sure whether they're going to be really happy for us moving students around, but there is probably another way that we can
so
if you've stated A, move on to this one, so I can have an option of sheet on the back and they can just pick the one that's right for them, let's say. Something like that.
Yeah, so it's this idea, I think, and of using these best resources to almost use this as a break in your flow chart of your lesson plan. So you can say, okay, if the outcome is this, then I'm going to do that, and the outcome is this, I'm going to do something else.
Yeah.
And it's using the AFL to kind of signpost not just what they know and the proportions that know one thing or another thing, but also deciding what I'm going to do next, really. And the idea that you might do one thing, depending on what they say, you might do another thing. But often what you'll get in your class is that you'll have one member of the class say one thing, another member of the class say another thing, and therefore they need different responses. So you use it as well to guide your differentiation. And so differentiation is based around your AFL rather than, say, historic data, something like that. There's always, I suppose, historic data is by definition old and slightly out of date, and maybe not as relevant to the question right in front of you.
No.
So what I was going to do, if we had a bigger group, is send people off and do a task, which I'll just pop on the screen, but you might say it might not be appropriate considering it's just us, which is to have an explore of those STEM resources and do that. If you're doing it on your phone, I think that might not be so practical to do that. It might be better if you're doing it with a computer instead. So perhaps instead we might have a look at this. I think this was shared with you as well.
Yep.
The idea that you've got hopefully a few different bits and pieces, and you've got your EEF's recommendations on the right here for what your science department should be doing. And I would suggest that it would be interesting to do a bit of an audit, especially with starting up a new school, what your science department looks like in the future, and which of those 7 things or how well you're keeping to those 7 recommendations. You've also got the link to the best resources that we showed you. And what you've also got is the ASC have put together some best steps programs, which are linked to those, but they're also linked to GCSE exams as well. You've got some stuff about Science Capital, which we're going to do in the next session, and also some stuff about practical work, Gatsby as well. Presumably, are you getting involved with designing new labs for the new building?
I am not. No, I think at least they haven't said anything about it. I don't know whether I'm going to be involved or they already have an idea on how they will look like. No idea.
All right. Okay. So the Gatsby resources are quite good for that. And then you've also got Cleeps as well, looking at that as well. Hi, Mark.
Hi there, Raj. I've just joined towards the end, if that's all right with you. I'm going to stay on the call, but in the background, I know I'm here to just take a look at what's going on. I'll let you carry on.
It's just the 2 of us, so we've gone through some bits and pieces, and we're just Petra's in a really interesting situation that she's in a new school. So am I right in saying you've just got year 7?
Yes. Yeah.
And that you're based on the site of an existing school.
Yep.
And then once you get a few more year groups in, then you'll move over to another site.
Yeah, we are just starting the building now, so it's going to be a completely new building. But it will take a while. I think it will take about a couple of years to be built.
Okay. And then it will be kind of setting up a science department from scratch. So that's really exciting. And then and your science department as well will grow as you go on. And it's really interesting to, I suppose, with this cohort, this year 7 cohort, to start on the right tracks with that as well.
I am definitely going to be privileged because I know all of them. They know me. So yeah.
Yeah.
They have no excuses that, oh, Miss didn't teach us this, Miss didn't teach us that, because I know exactly what I've taught them. So no excuses for not knowing.
Okay. So yeah, I think probably what I would suggest is it'd be really exciting to have a look at those EEF 7 recommendations and see if you can have those intrinsically in there. And presumably as well, practical work is going to be quite exciting when you get into those new labs. And I would suggest using that the Gatsby report as well to guide what practical work looks like in the starters as well. And you can use it as well to justify certain decisions that you're making as well to do with practical work. In terms of, for example, the proportion of technician hours that you have compared to your students. That's in there as well. And so you can justify saying, okay, we're at a stage now in which we've got another year group, we need to employ another technician for that. And you can maybe ask your SLT for a little bit more cash to do that. Lovely. Is there anything else that you wanted to go through, or any kind of challenges on the way, do you think?
There will be probably a lot of challenges. There were this year anyway, setting up the new school and trying to figure out how to make it work. I can't really think of anything in particular. The practical work is definitely one thing I'm going to look at, because obviously in the last couple of years there weren't many practicals done in the labs anyway. So yeah, I think I'll definitely need a bit more support with the practical work and how to set it up in a way that it's done fluently and safely enough. Yeah, that's something I would definitely like to pay attention on.
How have they transitioned from primary school? Because presumably their primary school last couple of years have been quite disrupted, been plunked into a secondary school. How have they transitioned, and then is there quite a lot of variation between their experiences of science as well?
Well, there is always a difference between them, but overall they actually settle in quite well and quite quick, I would say. It makes it probably a bit more difficult because they are mixed ability sets. So some of them will be obviously quicker than others, but I taught mixed ability last year, so that's not probably my main concern. But I think they actually did quite well, and they knew what was expected of them fairly early in the year, I would say.
Oh, fantastic. That's really good. If there are gaps that you identify, one of the things that I recommend, particularly to do with practical work, is that while they might not find it easy to do practical work at home, unless they've got a whole science suite at home or anything like that, which I'm sure we wish all of our students had, but realistically, what you could do is you could use these PhET interactive sims. I don't know if you've seen them.
I've used them. Yes, I've used them quite a lot. I really like the site. Yeah.
If you've got some gaps and things like that, then this is a great way. So again, with your electrical circuits that you said that you're going to do, whether or not you're setting preps or anything like that, these are quite nice to give students virtual experiences of practical work. Did you have a go with the resources as well on here?
No, I didn't actually. No, I've only used the simulations, nothing else.
So underneath the sims, you've got teaching resources. So again, it's a free sign up. And then you've got worksheets. And the nice thing that you can do with these is that you have a few different worksheets for these different activities. So it's quite nice for differentiation as well. You can quite quickly download 3 or 4 different worksheets and then work out which one of those suits your students best, whether that's differentiation by level of difficulty, but even just how they learn. So some students might want an extended project-based one. Some students might want something that's far more structured. So again, if you go on to any of these sims, and then you'll have a activities tab, and then you'll have lots and lots of different resources on there so that you can do that, and they'll have you take the students through.
And you can set it up as a homework, I suppose?
Yeah, a homework, or if you've got laptops in lessons, then if you need to set cover work and things like that. But yeah, it's quite nice with the homework because the students can spend a lot of time playing with it. So it's quite well suited to things like homework as well. With that. So that's quite nice as well. And it saves you from just, well, it's all planned already. So it saves you from just saying play with the sim or do something like that. You've got those activities. But I think what I'd really recommend is to actually use the fact that there's more than one, so that different students will do different things. And then they can maybe even come back to class and share their different investigations. So you can almost have a mini conference.
Yeah, that sounds pretty good.
As well. So that might be something to do, especially if you've got year 7s, and they will have had all had different experiences during lockdown. They'll come to you with different things. So filling in those gaps and getting them to do that practical work they haven't had a chance to do while they've been away during lockdown, that might be a way to do that. Is there anything else I can give you a hand with? I know it's been a weird session because it's just been the 2 of us, but anything else?
No, I think that was actually quite useful.
Oh, fantastic. So
We're probably gonna try out those resources, yeah.
Our next session that's going to be in June is focused on science capital. So the idea of that we're looking at what the students know, what they bring to their lessons, what they understand, and really hitting those students that will say to you, science is not for me, or I'm not interested in this, or how is this relevant to my life? And converting them and saying, okay, right, well, if you decide, for example, I want to be a hairdresser or a beautician or something like that, you've got to know a lot of chemistry to make sure that those chemicals within those aren't harmful to your customers.
Yeah.
So actually repurposing their existing knowledge as science knowledge and making sure that every single student in the class feels like it's relevant to them. So that's what our next session is.
Brilliant.
Fantastic. So I think there's what I'll do is I'll send these links off as well that we mentioned, but they're also on this Science on a Page document as well.
Thank you very much.
Fantastic. Well, good to meet you, and I'll be excited to know how that new school goes.
Hopefully it will go really well, because at the moment we are in an outstanding school, so we need to keep up.
Fantastic, and it's so exciting to hear what your journey is going to be like. Lovely to meet you.
Lovely to meet you too.
Thank you, Katja. Bye now. Hopefully see you next time.
Bye.
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 Oof.
Gosh, that must have been really challenging with just the one participant throughout. Well done.
I think she had planned just to be doing some marking while she was doing it. I'll better turn the recording off.
I mean, yeah.
But